All right, welcome to today's lesson. I know that it says that today the lesson topic is solving x squared plus bx plus c equals 0. We're actually going to work on the focus on the solving a little bit later on. Today we're just going to work on the factoring portion. So the factoring will be of expressions, trinomials of the form x squared plus bx plus c. So of the two objectives, we're just going to focus on the first one, and that first objective is factor trinomials of the form x squared plus bx plus c. I will give you the only definition that we have today, which is quadratic equation. A quadratic equation, just note that there are two possible solutions. There are cases where we might only get one solution, or other cases where there are no real solutions. So a quadratic equation is an equation in the form of ax squared plus bx plus c is equal to 0. And the key important thing here is that a cannot be equal to 0, because if it was equal to 0, 0 times x squared is 0. And so you're left with bx plus c equals 0, which makes it a linear equation and no longer a quadratic equation. So a couple of things to note in our first example. If you have your diamond math problem worksheet, you might want to take that out just to reference. I will be referencing that. And if you have your factor chart on the cardstock paper, might be helpful to have those too. We will be working on factors. So looking at this first example, remember I said earlier that a trinomial of the form x squared plus bx plus c. In this first part, b is going to be positive and c is also going to be positive. So what we're looking for in this first example, x squared plus 9x plus 20, is we are looking for our factors of 20. Okay, so in the first thing that we're looking for is two numbers or two factors that multiply to c. And remember, c is going to always be our last term. Then the next thing that we're going to look for involves our b value. We want to take those same two numbers that add to b, which again, b is always going to be our middle term. Okay? So if you have your factor sheet, okay, look and search for 20. I don't have that readily available now, so I'm just going to list out the factors of 20. So we have 1 times 20, 2 times 10, and 4 times 5. You could also keep going and say, oh, 5 times 4, but remember that multiplication is commutative, so 4 times 5 is the same thing as 5 times 4. So now what I'm going to do is I'm going to look to see, of these three sets of factors, which one's going to add to positive 9? Well, 1 plus 20 is 21, not equal to 9. 2 plus 10 is equal to 12, not equal to 9. 4 plus 5 is equal to 9. So this is exactly what I'm looking for. Now, the only way to get to multiply to x squared is x times x. So I'm going to have two sets of parentheses here. And so what I'm looking for is I'm looking for two numbers that multiply to 20, add to 9. Those are 4 and 5. Actually, I'm going to get rid of these parentheses real quick, because this 9x can be rewritten as these two factors. So this can be rewritten as 4x, and this could be written as 5x. Okay, so now if I bring down my, and those are both positive, by the way, if I bring down my x squared and I bring down my plus 20 at the end, notice I have now, instead of a trinomial, I have a polynomial of 4 terms where I can combine like terms with 4x and 5x. Now the reason why I did it this way is because our last lesson we did factor by grouping. And so if I group my first two terms and I group my last two terms, I am searching for the GCF. So GCF between x squared and 4x is going to be x. So I'm left with x plus 4 inside of the parentheses. And then between 5x and positive 20, that has a GCF of positive 5. So when I divide by 5, 5x divided by 5 leaves me with x. 20 divided by 5 leaves me with 4. Now, if you don't get the same exact thing in both sets of parentheses, you've done something incorrect. So you want to go back and check your work. So now I take my two numbers on the outside, which is x and 5, and I write them in its own set of parentheses, x plus 5. Then I take my numbers on the insides, which is x plus 4, and that gets its own set of parentheses. Now, factor by grouping is not necessarily needed here, but what I'm doing is I'm prepping you for what's to come in the next lesson when we get problems that when A is not equal to 1. So that's the only example I'm going to show you where I do factor by grouping. So in example B, okay, when we take a look at this one, I'm going to show you kind of not necessarily a shortcut, but we know two things that are going to multiply to d squared. The only thing that's going to multiply to d squared is d times d. So even as a shortcut, you can say, okay, I'm going to set up two sets of parentheses where d is in the first part of both. So now I'm looking for two numbers that multiply to 24, and this is where your diamond math problems come in. So multiply to 24, and I want those same two numbers to add to 11. So 11 would go down here. So if you have to list out your factors of 24, that would be 1 times 24, 2 times 12, 3 times 8, 4 times 6. And again, if you find your factors that add to the middle number, you can stop. You don't have to continue on. So 1 plus 24 is 25, not what we're looking for. 2 plus 12 is equal to 14. Again, not what we're looking for. 3 plus 8 gives me 11, exactly what we're looking for. So I don't even have to test 4 times 6. So it doesn't matter which order in the parentheses it goes because multiplication is commutative. So I can put plus 3 and plus 8, and this is my solution. Okay. Again, you can also have d plus 8 times d plus 3. In C, notice the previous example, we had the quadratic term, the squared term first. If you want to rewrite it, you can absolutely do so. So that becomes t squared plus 10t plus 9. And so now I'm looking for my factors of 9, which would be 1 times 9 and 3 times 3. So I have two sets of parentheses. Only way to get to t squared is t times t. And now I add 1 plus 9 gives me 10, which is exactly what I'm looking for. So this is my combination. So t plus 1 times t plus 9. Again, order is not necessarily important there. You could have t plus 9 times t plus 1. Relating it back to the actual problem though, notice how 9 came first. So the order would just reverse. So this would be a 1 and a 9, and then it would be plus t plus t. Okay, but either answer is acceptable because whether you add or multiply 1 plus t times 9 plus t, that's the same thing as t plus 1 times t plus 9. All right, taking a look at problem D. Okay, so set up your two sets of parentheses. You know A goes in front because that's the only way to get to A squared. Since B is positive and C is positive, that means that both of these are going to be plus signs in here. Finding my factors of 36, 1 times 36, 2 times 18, 3 times 12, 4 times 9, and then 6 times 6. Again, once you find the combination, stop. 1 plus 36 is 37, not what we're looking for. 2 plus 18 is 20, not what we're looking for. 3 plus 12 is 15. Bingo, that's what we're looking for. So plus 3 plus 12. Okay, at this point, go ahead and pause the video. I'd like you to try E and F on your own. Once you have the solutions, go ahead and unpause it, compare your solutions to mine. All right, so for E, you should have gotten x plus 3 times x plus 4. Again, the order could be reversed. And for F, you should have gotten b plus 14 times b plus 3. Order could be reversed again there. All right, so let's take a look at example number 2. Let's talk about what happens when b is negative. So our middle term is negative, and our C term, our last term, is positive. So if we're talking about taking the product of something, we want two things that multiply to a positive 12, but when we add them, we want them to add to a negative number. So the only way to get those two numbers is both of our numbers have to be negative. So when we list out our factors, both of them are going to be negative. Okay, so parentheses start off x times x, because that's the only way to get x squared. And now I want to list out my factors of 12. So factors of 12 are going to be negative 1 times negative 12, negative 2 times negative 6, negative 3 times negative 4. And now we're looking for the combination that's going to get us to negative 8. So when I add negative 1 plus negative 12, I get to negative 13. Not what we're looking for. Negative 2 plus negative 6 gets me to negative 8. This is our combination. So I have x minus 2 times x minus 8. Again, you can switch around the order. X minus 8 times x minus 2. Again, in B, if it makes you uncomfortable, by all means, please rewrite it. Make sure that your middle term is still negative because 22 is negative and then 21 is positive. So now I'm looking for two numbers that multiply to 21 and add to negative 22. So both numbers have to be negative. So it would be negative 1 times negative 21. Negative 3 times negative 7. So there are no other factors. So I have two sets of parentheses. I'm going to put m in front of both just because we did take the time to rewrite it. I know both terms have to be negative because my middle term is negative. And so when I start adding, negative 1 plus negative 21 is negative 22, which is exactly what we're looking for. So x minus 1 times, m minus 1 times m minus 21. In C, go ahead and start off your parentheses with w in each first in each set. I'm looking for two numbers that multiply to 28 and add to negative 11. So with that combination, both numbers have to be negative. Factors of 28 are negative 1 times negative 28, negative 2 times negative 14, and then we have negative 4 times negative 7. So the combination that is going to add to negative 11, negative 1 plus negative 28 gets me to negative 29. Negative 2 times negative 14, negative 2 plus negative 14 gets me to negative 16. And negative 4 plus negative 7 gives me to negative 11. So w minus 4 times w minus 7. All right, one more together. All right, now the larger the number that we get, and even means more factors that we could potentially have. So I'm looking for two things that multiply to positive 60, add to negative 19. So I have negative 1 times negative 60, negative 2 times negative 30, negative 3 times negative 20, negative 4 times negative 15, negative 5 times negative 12, and negative 6 times negative 10. So now we're looking for the combination that's going to add to negative 19. We know that y is going to go in the first part of each parentheses. Both of them have to be negative, so we can put the minuses in there because a negative plus a negative is a larger negative, and a negative times a negative is a positive. So now when we add, negative 1 plus negative 60 is negative 61, not what we're looking for. Negative 2 plus negative 30 is negative 32, again, not what we're looking for. Negative 3 plus negative 20 is negative 23. not what we're looking for. Negative 4 plus negative 15 is negative 19. This is the one that we want. So y minus 4 times y minus 15. At this point, go ahead and pause the video. Try E and F on your own. When you think you have a solution, unpause and compare your answers. All right, for E, you should have gotten x minus 9 times x minus 3. And then for F, you should have gotten r minus 8 times r minus 9. All right, in our last example, here we're talking about what happens when our last term, C, is negative. So if you think about your diamond math problems, I'm looking for two numbers that multiply to negative 15. If we think about this, the only way to get to a negative number when we multiply is we have to have one positive number, one negative number. And then we want them to add to positive 2. So I'm going to give you guys a little helpful hint here. Your middle number is, if it's positive, that means your larger number is positive. If your middle number is negative, that just means that your larger number, and when I say number, I mean factor, is going to be negative. So in this case, in 3a, our middle number is positive, so between our two factors, our bigger number has to be positive. All right, so the only way to get to x squared is x times x. Factors of 15, I have 1 and 15, 3 and 5. And I know that because my middle number is positive, my larger number has to be positive, so I'm going to make both smaller numbers negative. So when I go to add here, negative 1 plus 15 gets me to 14, which is not what I'm looking for. And then when I take negative 3 plus 5, that gets me to positive 2, which is what I'm looking for. So in my parentheses, and I usually just put them in order of how I have it listed. So that's x minus 3 times x plus 5. The order in which you have it does not matter, meaning I could have x plus 5 times x minus 3. What does matter is that your larger number is the positive number. Okay, if you say x minus 5 times x plus 3, then this would have to be negative. Okay. All right, so taking a look at B, only way to get to C squared is C times C. I know I'm going to have one positive, one negative because C is negative, and I want my larger of the two numbers to be negative. So if I list out my factors of 18, I have 1 times 18, 2 times 9, 3 times 6. And because my middle number is negative, that means my larger number has to be negative. And so now when I'm adding these, I'm looking for the one that adds to negative 7. 1 plus negative 18 is negative 17. Doesn't work. 2 plus negative 9 gives me negative 7. That's what I'm looking for. So notice 2 is positive, so plus 2. 9 is negative, so minus 9. All right, looking at C. Only way to get to G squared is G times G, so that goes in front of both. My C value is negative. My B value is positive. So my larger of the two factors has to be positive. So if I list out my factors, 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. Larger number is positive, so make all these smaller numbers negative. And when I go to add, I'm looking for positive 13. So the one that's going to get me to positive 13 is negative 3 and positive 16. So minus 3 plus 16. And then finally in D, again, if you're uncomfortable here, please feel free to rewrite this. So that'd be h squared negative 10h, so minus 10h, and then negative 24 would make that minus 24. So multiplying to a negative, so only way to get to h squared is h times h. Those go in front of both. Multiplying to a negative, like we said, adding to a negative, so that means my larger number has to be negative. So 1 and negative 24, 2 and negative 12, 3 and negative 8, 4 and negative 6. So now I'm looking for the combination that gets me to negative 10. 1 plus negative 24 is negative 23. Doesn't work. 2 plus negative 12 is negative 10. Don't need to go any further. So that'd be plus 2 and minus 12. All right, I'd like you to go ahead and pause the video. Try E and F on your own. Once you think you have a solution, you can go ahead and unpause, compare to what I have. For E, you should have gotten R plus 4 times R minus 6. And for F, you should have gotten x squared, should have gotten x plus 4 times x minus 5. All right, what I'd like you to do now is take out your homework packet. We're factoring trinomials when a equals 1. I'd like you to do the 4 odd problems and complete those. If you feel like you need extra practice,